you guys, as we've mentioned many times, we're going to have a bunch of acronyms of ways of showing that triangles are congruent. And we started with a little bit of this a week or so ago. We're talking about congruent figures. And what's going to happen here is about 2 weeks ago, when we had two triangles, in order to show that those two triangles were congruent to one another, we had to have all of the parts. So if I'm looking at these two, in order to show that those two guys were congruent to one another, we had to say that segment AB matched to XY, BC matched with YZ, XZ matched with AC. We had to get all three sides matched out, and then we had to get all three angles matched out. So you had all these correspondence between parts. So a week and a half or so ago, bless you, we had to have all sides, all angles correspondingly congruent to one another, just so the figures for triangles. Well, as you get into triangles, a lot of the necessity or the things that are needed start to peel themselves back. You don't need as much information. So what happens here today, we're going to talk about two methods. Tomorrow we'll talk about another two. On Wednesday, we'll talk briefly about one that shows up not that often. So there's going to be only five ways that we're going to show that triangles are congruent to one another. And then on Thursday, we'll have another short quiz, because then on Friday, we'll start the stuff that takes a little bit more time. That's how you work with corresponding parts. So it's basically what we're doing today, tomorrow, and Wednesday, and Thursday, and adding like 2 steps to it. Yeah, it's pretty quick. Okay. So what we've done, like I said, what we've done in the past is that you had to have, in order to show the figures were congruent, you had to have all corresponding parts to show figures congruent. But now it's going to come down to just certain pieces. Okay. So we're only going to be dealing with triangles. And today we're going to talk about 2 ways that we can show that triangles are congruent. And what I want to do is use one of our progression boxes to kind of keep tabs on ways that we can show that things are congruent. Okay? So what I want you to do is, everybody got the progression sheet back, right? All right. So on one of your squares, or in one of your squares, excuse me, I want to put ways to show triangles congruent. And like I said, there's going to be 5 different ways. And there'll be plenty of space to do what I'm showing you, but today we're only going to talk about 2, so make sure you know where this one's going to be located so you can reference it back and forth. One of the ways that we're going to show that triangles can be congruent is this thing called side, side, side. Let me write this out for you. When you have triangles, if you have 2 triangles and their 3 corresponding sides are congruent to each other, triangles are congruent. I'll show you. I'm just writing down what it means. If 3 sides of one triangle are congruent to the corresponding 3 sides of another, triangles are congruent. Before we had to have all 3 sides and all 3 angles. What I'm getting at here is that all you need to have are all 3 sides. And it literally looks like that with the tick marks. And that's what I wanted you guys to have in the ways to show triangles are congruent. I'm going to use S, S, S for side, side, side. Hi again. And I'm going to draw a little picture that reminds me of what it looks like. Okay. If I've got all three sides of one triangle congruent to all three sides of another triangle, dun, 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 the triangles are. And this is where, and you know, all along I keep harping on you guys to mark your diagrams, draw your pictures, fill in the blanks, things like that. This is where marking your diagrams comes into play big time. Okay? It is a very, very visual way to show how things work. And as you guys know, as you use your progression sheets and you draw pictures and you're filling in blanks and you're doing all that stuff, it is super easy to see how this stuff is going to play itself out. Okay? It winds up being super fast to play itself out. And that's what we got. Okay? The other one that we're going to talk about today is called side angle side. And what I want you to notice, look how the lettering goes. S, S, S. It means it's 3 consecutive sides. When it goes side, angle, side, what happens is you have a side, then an angle, then a side. That's what I mean by marking diagrams, to be able to decide which of the 5 will wind up with. Okay? And that's what this looks like. The angle that's between the 2 sides that are congruent is called an included angle. Just means it's in between. Okay. So you have side, 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 side angle, side. And like I said, have a picture of what it looks like so it reminds you of the setups. What do you think AAS stands for? Angle, angle, then a side. So you've got 2 angles in a row and then a side. And then what do you think angle, side, angle stands for? Well, I should say ASA. Where's the side? In the middle. It's between the 2 angles. The side is then included as opposed to the angle being included. And our favorite thing in the whole wide world is, what don't you see? There's no ass in math. This is where it comes from. There's no way to show that there's a thing called angle, side, side. It's crack math, right?
Do you know why?
Hmm? Why is there no ass in math?
Yeah, you explained
Yes.
it before.
Yes. There's a thing called, it's called the ambiguous case of triangles. What happens put your pencils down. What happens here with this thing called, they never write it as ass, they write it as SSA. Because,
Well,
yeah.
but that's basically ass.
It's the same thing. Anyway, so what happens here is that, eventually you can have 2 sides that are congruent, but you don't have the angle afterwards. So depending upon where this angle is located, it may or may not work. It depends if this angle winds up being acute or obtuse, if it works correctly. And it's nothing that in a regular geometry class that we ever use to prove stuff, because it doesn't always work. Okay? There will be a case that we will see that this does work, but we won't call it ass. We call it HL. Why? What kind of triangles have a hypotenuse? Right triangle. In a right triangle, you have a right angle. Does everybody agree? Now, in a right triangle, every right angle is congruent to every right angle. Okay? Now, also, do you guys remember this thing called the Pythagorean theorem? That only works in what kind of a triangle? A right triangle. So if you happen to have 2 sides of a right triangle, a hypotenuse is the longest length, so it's across the right angle. The L stands for a length. Okay? It could be either of the other 2 sides. So if this is 6 and this is 10, this is 6, this is 10. are those two sides equal to each other? 10 is equal to 10, 6 is equal to 6, that's a right angle. So if you look at it, that's angle side side, isn't it?
Yeah.
It works in this case because Pythagorean theorem tells you 6 squared plus something squared equals 10 squared. Well, what's 6 squared? 36. What's 10 squared? 100. What's 100 subtract 36? And the square root of 64 is? So this would have to work. The ass in math only works if it's a right triangle. And we don't call it ass, we call it hypotenuse, because there is no ass in math. All right, it was a really good question. Again, this is something you don't have to worry about this for right now. We'll talk a little bit about this idea of what's called hypotenuse leg on Wednesday. It's a case that shows up with right triangles. But more often than not, when you have right triangles, you'll be able to do something else than hypotenuse leg. But it doesn't always work. Right? That's where it comes from. That's why we call it ambiguous. In Algebra 2, you guys will learn something called the law of sines. We actually do a very small amount of it in trigonometry as we start second semester. It's how you find missing side lengths of a triangle if it's not a right triangle. And the law of sines have rules that work with what's called the ambiguous case. There are little shortcuts and things you'll learn in Algebra 2 about it. It's super easy to work with, and it's just one of those things that shows up from time to time. Okay. So anyway, back to this. We've got 3 sides. You have to have all 3 sides congruent to one another. 2 sides and the angle in between. If that occurs, then we know we have triangles that are congruent, which basically then means we can start doing triangle proofs. Okay. Now, these triangle proofs are so much easier than the ones you guys were just doing. Let me show you an example. A lot of times, triangle proofs will look like this. They'll give you a diagram and a very simple given and proof stuff. Take a second, draw that up. Yes, ma'am. Not today. We're just going to slowly get through. I don't want you guys to get too overburdened with all the rest of the lettering and stuff today, because you're not going to have any problems that use any of it. And then tomorrow, you're just going to have problems that use the ones we look at tomorrow. On Wednesday, we'll mix the 2 sections together, so you'll have to come up with the idea of which one happened. Now, just like we've always done, I just put a piece of gum on.
No, I thought you were, because you were stop, and I thought you asked for 2, and I said thank you.
Oh. Now, just like we've done in all of our other proofs and things, we always start with our given statements, we mark our diagrams, we fill in blanks, and we're looking to see if there's any progressions. We'll know if things have progressions to them if one of your given statements happens to have a definition, like a midpoint, or an angle bisector, or a segment bisector, or perpendicular, or any of those things. Yes, sir. Yes, there are 2 sets of given statements. They just run horizontally as opposed to vertically. Okay. So just like we've always done, start with your given. LM, congruent, NP. Now, normally, your diagrams aren't going to be marked for you, which means you have to go and do what to the diagrams after you write that down? Mark them. So you look at it, LM, NP. Okay? That's just a statement, no definition, there's nothing else I can do with it. Okay, so I go to the next one. Next one says LP. And again, we have them marked. At this point in time now, it's reliant upon you to look at your progression sheet to figure out what you can do next. Now, your progression sheet should have a diagram that looks somewhat similar to that. and it has a big old hint on it. It tells you to look for something. Exactly, very good. Everybody remember the thing called reflexive side? Reflexive side is that shared side. Do you guys all see that there are two triangles here that share LN? So in our or on our progression sheet, on our progression sheet, there's a picture that shows us that has a shared side. It says look for shared side. And when we did that, we would write down that side, in this case the letter to be LN is congruent to LN. Because you're always congruent to yourself. So I can write down LN congruent LN because reflexive, the reflex prop, if you want to write it like that, is fine. So if something's congruent to itself, what do I now do to, to the diagram? Mark it. Are your triangles now congruent? Yeah. Because now the triangles are congruent because you've got all three sides matched up with all three sides. Excuse me. And that's all you have to write. What do you mean they gave it to us? The proof? Well, they gave it to you, but how does it work? That's what you have to come up with. It's not a given. Right. So let's backwards out of your logic for a second. How many total things did we just write down? 8. You had 4 statements, 4 reasons. Okay, so there's 8 total things that we just wrote down. Are we okay with that? Of those 8 things, 4 of them were given. So if you look at it, 4 of those statements were given to you. Actually, 5 of those 8 statements were given to you. LN, NP, LP, NM, those 4 were given. They also told you what you had to prove. Triangle LNN versus triangle NL. Right there, if that's all you wrote down, isn't that 5 out of the 8 things? That's more than half, isn't it? Okay, that's good. Then you look at your progression sheet. Your progression sheet has a picture that tells you about the reflexive property. So did you really even have to think about that one? No. So then you go down to it. That's 7 out of the 8 things you have to write down for this proof as either given to you or directly on your progression sheet. Which means, really, the only one thing you had to think up of on your own, ladies, please put away your phones. Thank you. The only, oh wait, please. You can put it in your purse or your pocket, thank you. The only one thing you have to worry about then, you don't have to use the attitude about it, I'm just trying to help, is looking at which setup you have. In this case, it's side, side, side. One thing you have to think of. Everything else is written out for you. I'm trying to show you guys that you don't really have to think with most of these things. You have to have a sheet in front of you that's correct and work it. Okay? Try that one. This one. We use one that actually has a progression to it. Again, always start by writing out your givens. Draw the picture and label it. Always draw the picture and label it. Okay? Always, always, always. Okay? Always. everybody should be done with their quizzes by tomorrow. I'll get those quizzes to them too. So, as you go through these, again, it's a matter of going through your progressions, marking your diagrams, looking at what information you have in front of you. You always start, ladies and gentlemen, enough. You always start the same way. Write down a given, mark the diagram. And it's marked. Okay? There's nothing left for me to say out of that one, so I go to the next thing. The next thing says, D's a midpoint. Okay. You write it down. What does the midpoint do? Cuts it in half. According to your progression sheet, what are you supposed to state then? That what two segments are equal or congruent. Now, when I mark my diagram, since we're dealing with congruency for triangles, there's not going to be a lot of algebra stuff here, guys. So I'd say 95% of the time, you're just going to say segment congruent to segment. Or when we have angle bisectors, we'll do angle congruent to angle. Okay. So I would just write down, now that I marked my diagram, what two segments? Well, AD and DC. Okay. Oh, sorry. My bad. It should have been definition midpoint. I'm sorry. Sorry, I looked up and I saw given. I thought it was on my second given. Sorry about that. We have now used up all of the given statements that are in front of you. Yes, ma'am. Why is that? Right. No, I want to say equal or congruent. Perfect. Everybody here? No. All we have left now is to go through. You look back at your diagram. What do you have marked up? Well, you only know two ways to show triangles are congruent. There's nothing in here that helps me get an angle. I can't just assume it's there because there's no ass and mass. You can't assume anything. So I have to go back by looking at what information can you take from the diagram. Well, according to our progression sheet, we can infer reflexive. Do you now have triangles? Yeah. Because of what? Yes, ma'am. You don't have to. The reason I don't do that is because it gets really messy inside the proof with so many different symbols and stuff. The only symbols I want you to make sure you guys use are angle symbols and triangle symbols. Everything else is fine. You don't have to. If you want to, that's fine. Go for it. I don't, because as you can see, my handwriting's already something. So the less I have in front of it, the easier on your eyes it might be to see. Okay. So then I'm done with triangle. Was it A? Let's see. So now you had, I want to keep showing you guys how little of this stuff you have to come up with on your own. There's 10 total pieces here, correct? The first 6 of them were all coming from the given statement, which means right off the bat, 60% of the proof is done for you. If you add in that triangle statement at the very end, that's now 70% of the proof is done for you. So really, you only had to figure out, by looking at the diagram, you had to figure out, oh, you had a reflexive property, and then which of the ways of the triangles being shown congruent. 70% of this proof is in front of you to start with. All you have to do is write down the information that you have. It goes that quickly then, guys. These are so much easier than segments and angles. A lot less thinking. Okay? A lot less thinking. Stop. Draw the pictures and fill in the blanks. Seriously. Yeah. Okay. You guys do this one. So with any luck, hopefully you guys got 4 steps right out of the way from progressions. 4 total steps right out without even having to think. B is a midpoint of AE. That's given. When you have a midpoint, you know you've got 2 segments that are congruent to each other. You automatically go to the diagram, you mark them. AB, congruent, BE. Definition of a midpoint. Okay. Go to the next given. Same deal. You've got a midpoint. B is a midpoint of CD. Go back to the diagram, mark it. If that's the midpoint, and I mark them. Definition of a midpoint. From here, you've gotten 4 things written out, 8 total. Now you got to look at the 2 possible ways you know how to prove triangles congruent. All 3 sides or side angle side. Is there any way for us to show that you've got AD and EC congruent to one another? No. But what do we have? You're saying vertical angles. I heard vertical angles. What are the letters of the vertical angles? I can't say B. How many letters do I have to have for angles? 3. Angles need 3 letters. Everybody okay with that, right? If you look at your progression sheet, you should have a square that says, hey, knucklehead, look for vertical angles. And you should have a picture that looks kind of like the bow tie. Okay? And you have it marked in there. So you had to identify that you've got those shared common vertex, opposite sides making lines, because you get that vertical angle. So if you say angle A, B, D, what do the letters have to match up from the other direction? Watch the letters. Look at the tick marks. If I'm going A, B, D, what do they have to be? It's got to be E, B, D. Everybody see how I'm starting with that A first? A has 1 tick mark to the angle, to 2 tick marks. You have to follow the correspondence of your tick marks. Yes, ma'am. It doesn't say that. We don't know that information. Hey, well, there's no what in math?
Yes.
Can't assume it. You can't assume it. It's okay. All right. We can't assume that. We can't say that they're congruent to each other because there's no way of me saying that for certain from the diagram. There's no information for that. But what I can infer from the diagram is that I can say that these 2 angles are congruent because they're vertical. That's something you can do. Just like reflexive sides, you can say that it's a shared side because it's something in the diagram that you can see. Okay? So that's why when I say, yeah, kind of the same thing. Since I'm starting at A, B, D, it goes from 1 tick mark to the angle to 2. The corresponding lettering has to match. That's where it gets a little ticky-tack. Okay, that's about where you get a little ticky-tack on that. So it would be angle E, what is it? Was it EBC? Okay. So now, are your triangles congruent? Yeah. Because of what? Side, angle, side. How many total steps are in this one?
12.
12 of them, right? The first four, please. The first four of them are straight out givens. The first four of them are given to you. Well, if you think about it, 8 out of the 12 steps are verbatim from the given and your progression sheet. The triangle statement at the end is given to you. That gives you 9 out of 12. Again, that's 75% of the proof itself is done for you. Which means all you had to do was kind of figure out. You just had to figure out where does this vertical angle come into play, and where does the side, is it side, 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 or side, angle, side, or one of the other ones we'll get to later on. Remember, guys, over half of the information for any of these that you start with is going to be in front of you right away. There's not much thinking you got to do. These should be really, 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 really easy. And they really should be. Other questions? Okay. One more. Another one with the progression. Okay? Another one with the progression. Let me kill that light so you can see the green a little bit better. I forgot that I used green and I shouldn't have. Okay? Take a second and do that one. Follow your progression sheet. That's what it's there for.
Is that a D?
Yes. Just make sure you have a square that you put this one. Okay? Then make sure you put like 5 spots. We're only doing the first 2 today. We'll get to the other 3 in the next day or 2. We are running short here. Kind of jump in and make sure we're steering in the right direction. If you're given perpendicular, what does your progression sheet say to do next? State the right angles that are formed. Okay. So you go to your diagram and you draw where the right angles are created. Since they're perpendicular right there, I know that those 2 angles have to be right angles. So I have to say what they are. Angle ADB. I can do that, BDA. Either way, it's fine. Yeah. I'm always out in. I just how I think. And angle CDB. Perfect. Yeah, all right angles. And that's the definition of being perpendicular. My progression sheet tells me to do that step first. After I have right angles stated, what do I say about those 2 right angles? They're congruent to each other. So then I would say angle ADB is congruent to angle CDB, And again, according to my progression sheet, the reason is all right angles are congruent. Okay? Have I completely used up that progression? Yeah. So I go to my next given statement. The next given statement says AD is congruent to DC. And I mark my diagram. Now that I've marked my diagram, what do I have left? Oh, but we can get another side though, but you're right with the side, but why can I say BD? Perfect. Absolutely. Yeah, what she's getting at, guys, is that sometimes you have to overuse some segments. It doesn't mean that we've used, since we've said BD was perpendicular, it doesn't mean that you can't reuse it later on. There's no rule that says that. It's still reflexive. It's still a shared side between the two triangles. So you still know that they're congruent to each other. Or sorry, they're congruent to itself. So you would literally write out BD congruent to BD because of the reflexive property. And now do you have your two triangles that are congruent? Yeah. Why? Perfect. ABD. It usually is. No. Oops. Trying to get rid of that yellow piece, but not happening. Anyway. Now, if we go back to what you had here, guys, there's only 10 things. You knew 7 of them, or I'm sorry, you knew 8, 9. I'm sorry, I can't even count. There's 12 things. Hello, math is hard. Of the 12 things, you already knew, what, 9 of them? I already posted the homework. It's on page 230, I believe. Yep, it's on page 230. There are 4 proofs for you to do. They're of this complexity. That's it. Nothing crazy. All right? You 9, 10, 16, and 17. All right? They might be 5 or 6 steps. Not yet. Not yet. We won't. Usually what I do the first day, you use the ones you learned about today. Tomorrow you'll use the 2 that you learned about tomorrow. Wednesday, you'll make a decision on which one. And it's really easy, especially if you start marking your diagrams. You'll see what it's leading you to. Hey, it's better than none, right? Remember, your proofs are usually 70% done, so if you have to half understand it, you can get 15% of the rest of it done then.